Well, once again, hello everyone. Thanks for joining us today, depending on where you are, morning, evening, or afternoon. Welcome to the College of Engineering Conversational webinar. We're going to discuss MS in robotics. My name is Hirsch Mehta. I'm a recruiting specialist within the college, and I'd like to also pass it on and introduce to you our great team that we have today. We have a student ambassador. We also have the professor that teaches the program, as well as we have two amazing staff members that are going to be someone that you're going to work really close to regarding courses. So I like to start off by passing it to Kirsten first, and then we'll move it forward.
Hi, everyone. My name is Kirsten Bilas, and I'm the Senior Academic Advisor for what we call the departmental team, which we do focus on robotic students such as yourself. Um, I'm joined here with my colleague, Laura Haskell, who's Assistant Director, and we are very excited to see you on campus in the fall. Laura?
Hi, everyone. Like Kirsten said, my name's Laura Everly Haskell. I'm one of the assistant directors on the advising team, but I also do carry a caseload alongside Kirsten on our departmental advising team. So nice to be here, and we're excited to meet a lot of you this fall. I will pass it over to Rifat.
Thank you. This is Rifat Sipai. I'm one of the faculty members of the MS Robotics program. Also, I'm a faculty advisor. I'm also faculty advisor of the MS Mechatronics program. And we are joined with Pujit today, one of our MS Robotics students, one of our ambassadors. Pujit, you want to introduce yourself?
Hey guys, I'm Pooja and I'm a master's in robotics student here at Boston campus at Northeastern. And I'm in my third semester right now, and I'm happy to see you all. Welcome to the Northeastern community.
Perfect. Thank you, everyone. So just some housekeeping rules. On the bottom of your screen, there's a Q&A feature. We 100% advise you to type in your questions there, and we will be answering them throughout the session. And if there's a more common question, we'll answer that towards the end of the presentation. So without further ado, what is COE and what is our mission? So it's as an academic institution, our main product is people. Our success is based on the quantity and quality of the people we produce. So something our dean often says is good engineers solve problems, great engineers solve important problems, transformative engineer discover and solve important problems. And that is exactly what Northeastern does. And this is exactly what we do within the college. We produce transformative engineers, students, and faculty with a global impact. And that is exactly what Professor Safaya and his team does within the robotics program. So I like to pass it on to him.
Thank you. First off, we will have a more comprehensive orientation session at the beginning of the semester, around the beginning of September, and to cover more details. But today's is just a very quick highlight and high level. But if there are any questions, obviously, we'll be able to dive in. Our robotics program at Northeastern is quite unique because it sits in 4 different departments: computer science, ECE, mechanical industrial engineering, MIE, and physical therapy. And each department has a faculty advisor. So if your home department is in electrical engineering, then you're advised by Professor Singh. As an example, if your home department is in mechanical, then I'll be your faculty advisor. And advisors, among others, one of their main roles is to guide students one-on-one on their needs, help them customize their learning endeavors, and decide on course selections and other aspects in their academic preparation while they're at Northeastern. So again, as I said, one of the unique aspects of the program is it sits on multiple departments. That's going to become more obvious actually when we look at the courses. Let's go to the next slide. So regardless of how you do it, every student graduates with a total of 32 credits. Each course is 4 credits, which is equivalent to 8 times 4, 8 courses if you follow a coursework only option that's at the bottom. I'll start from there because it's easier to explain that one. So your students take 8 courses while they're at Northeastern, and the standard load is 2 courses per semester. So that corresponds to 4 semesters of courses. And that can be completed in about 1.5, 2 years, depending on how you spread your courses out. Then from the bottom to the center row, project option is very similar, except instead of taking 8 courses, students take 7 courses, but they take their 8th course as a project supervised by a faculty member, and that's usually a lab level work that entails a semester-long research effort. And then the top option on the top of the list is the thesis option, where students actually take 6 courses instead of 8. But the remaining missing 8 credits are supplemented by 2 semester efforts, 4 semester hours of MS project and 4 semester hours of MS project, MS thesis. And that all together again combine the 32 credits, and depending on how things go, that can take 2 years, a little longer, and of course these are like plus and minuses, because the thesis option sometimes may take a little longer than 2 years depending on the scope of the research. And obviously not listed here, but I'm going to show an example. Along the way, students will have some time off, whatever that means, in summertime, which they could use to go on co-op and attain a real-world work experience, whether they are a domestic student or international student. This option is also available. Next slide. Now, what are these courses? Again, we're going to get into details at the orientation, but overall, every Master of Science Robotics student takes 4 core courses, and 2 of those core courses are from their home department. Whichever is your home department, you take 2 core courses from there, and then you take 1 core course each from the other 2 departments, mechanical, electrical, and computer science, as we speak right now. So as an example, if you're a mechanical engineering home department student, then you take those 2 courses listed there, and then take 1 electrical core course and 1 computer science core course, and you have completed your 4 core courses. And that is the main idea of the truly integrating departments into each other, because every student, irrespective of their home department, is exposed to mechanical engineering, electrical and computer engineering, and computer science courses. Now, these are obviously only just 4 courses, and if you're following course-only option, then you have 4 more courses to take to complete to 8 courses. And those courses are listed in the following slides. Let's take a look. So now some maybe a quick update here before we go to those electives. We have recently added biomedical and rehabilitation robotics in our programs, and we have been advertising it because this is now an additional component in our program as we become more diverse and more multidisciplinary. And so the bottom of the slide here, you can see the added biomedical and rehabilitation robotics core courses. And now that's also incorporated into the curriculum. So students willing to pursue that direction within the MS Robotics program, they'll be able to do that as well. And regardless of how you actually combine your courses or which home department you're in, at the end, you are getting an MS, Master of Science in Robotics degree, a diploma that says that. Okay. All right. So now let's go to the next slide, where we have a look at what are the types of electives that you can take. Having taken your core courses, what electives are available to you? And this is, again, another indication that the program is truly integrated with different departments. It doesn't matter which home department you have. You can take courses from every other department that offers this list of elective courses. So this is just the list for the computer science, because it doesn't fit on a single slide. So I have multiple slides to show you all the electives. But again, remember, you don't have to be a computer science student to be able to take computer science courses. And you can assemble your electives as you want, as your learning needs are, or your goals are, etc. So here are all the computer science courses. Next slide. We have mechanical and so we have electrical and computer science electives listed here. And next slide, we have mechanical and industrial engineering, I believe, courses, as well as the new additions of physical therapy courses, and that we will be actually growing as we go, and as the demand goes also grows towards this program. Overall, as you may have noticed, the number of courses available for electives is quite broad and encompasses control theory, advanced control, robust control, biomechanics, mechatronic systems, computer-aided design, machine learning, machine vision, deep learning, human factors engineering, statistical methods, wearable robotics, mobile robotics, sensing and navigation, you name it. And again, keep emphasizing that. As an example, let's say you're an electrical engineering student in the MS robotics program. You're free to take all your 4 electives from computer science if that's what you would like. All right, next slide, please. Now, the list of faculty that teaches and does that do research is also growing. As of, let's say, this spring, this is the list of faculty that have a direct, let's say, contribution to robotics research and teaching on campus. And there are other faculty who also contribute, but maybe not directly, but maybe indirectly through collaborations. I didn't even list them because the list would not, it probably would not fit here. But the list is growing. This is a program that is on the top priority for Northeast University. And my personal anticipation is that this list will just keep growing in the robotics field, which means more course offerings and additional opportunities for research and learning, obviously. Next slide, please. What does a typical semester look like, or 2 years at Northeastern? Is a very, let's say, a sketch of how it may look like. And in this case, year X is going to be 2025. Incoming class fall semester. For example, they might be taking ME 5659, that's control systems. It's a core course in mechanical. And then ME 5250 is also a core course in mechanical. This is an example for a mechanical engineering student home department. And then in spring semester, that actually will the yields and obviously change. So spring 2026, you might be taking EC 5550, mobile robotics. That's also a core course. And then you might be also taking computer science, robotic science and systems, and that's also a core course. So in some sense, if you know your first 2 semesters, you have cleared all your core courses. That's an example. It doesn't have to be this way, but we usually do the core courses first and building a foundation. Some of these core courses are also prerequisites for some more advanced courses. And then you get to your summer. That's summer 2026 for you. And you have a number of options. We do not guarantee courses will be offered in the summer. But some courses are offered in the summer. If they are, you can take them to kind of offload your future semesters. Or students opt to go on co-op. And our co-op team helps students to connect with companies, and you go through an interview process, and Pujit probably will be able to tell you more about those. And then you will go and work at a company and do real engineering work and have an income, and also gain significant, very critical real world experience. In the summer, that's 4 months. You can go on co-op, and there are other options I'll tell you in a moment. Let's say your summer is finished, whichever activities you pursued, you come back. Year Y is 2026 fall. You take 2 more courses. And then 2027 spring, there are 2 more courses to finish with mechatronics, let's say computer vision as an example. And that with the graduation 2027, at the end of April, students graduate, or in the beginning of May, students graduate. This is one of the options. Now, if you say, well, what if I do a project? Then you remove one of the electives from the list and then swap that with a project course. And if you say, what if I do a thesis? In that case, you remove 2 electives and then swap them with the corresponding thesis and project courses, 4 credits each. And what if I want to do a longer co-op? You can go up to 8 months of co-op. In that case, you could do 4 months in summer and then 4 months in the fall, 2026, as an example. In that case, because you're doing co-op in the fall, your graduation will be pushed out by a semester, naturally, but you'll be able to squeeze in an 8 months of real-world experience. So these are some options, and then there are many details. We'll get into those maybe in the Q&A. Next slide. And we are expanding. Obviously, the demand towards advanced degrees in robotics is on the rise, has been on the rise for a very long time, and it just keeps going and accelerating, and as you know it. And so right now, Northeastern College of Engineering and Curry College of Computer Sciences have launched Master of Science in Robotics in our Seattle campus. And we are offering 25% scholarships for those who are gonna pursue the same degree in Seattle instead of in Boston campus. Next slide, please. Next steps. Arsh, you want to take over from here, or?
Yes, I'll take over from here.
Thank you.
So this is a roadmap that we love for all of you to remember and to know, and you can take a picture of this. So once you are accepted to Northeastern, you would have seen in your portal, which is normally your Slate portal, as well as your Northeastern email of what you should be doing. So at this point in time, for many of you that do have, I see a lot of questions about course registration, you have already paid the enrollment fee. And that's normally how that process will go. And then, of course, you want to make sure that you are starting the other steps. So applying for I-20 for your international student, that is something you will be doing. And then if you're not an international student, your roadmap is a little bit different. So these are just a good way to look at what you should be doing and where you should be at this point in time. Definitely take advantage of using, take advantage of making sure that you're tracking your emails with us, especially regarding registration, because there's a lot of key information there. And it's also available on our website. But if you have any questions, you could definitely put the emails in the chat for you guys to just look at it and take care of. But definitely follow the roadmap. At this point in time, many of you should have received emails on registering for your classes, and that is a good way to do it. And then you will get more in communication regarding orientation and everything else along those lines. So just make sure you are very actively looking at your Northeastern email, because once you are a student at Northeastern, majority of the communication goes through that pipeline. Outside of that, we always, like we said, we have a graduate ambassador. So if you have questions regarding some specific work of like courses or like the experience of like if you're someone that's moving to Boston or the Seattle campus, or you just have questions about student life and stuff, they are a great tool to connect with. So that is their email address that is on the screen, as well as that QR code would take you to their page as well. So this is a good way to untool. But something I will like to say is that Pujit is not responsible for your courses that you'll be taking, and he won't help you with registering for classes. So definitely don't spam his inbox with those questions, because that is something that we in the admissions and advising team could definitely help you and navigate you on that piece. So I'd like to have Pujit introduce himself a little bit more and to tell him a little bit about his experience and what his interest in why he chose robotics.
Hey guys, yeah, so I have an undergrad in mechanical engineering, and after that, I worked for 3 years in a robotics startup where we were like basically developing painting robots. And yeah, that field was really interesting, and I wanted to learn more about that. So I chose Northeastern because the curriculum was like really flexible, right? You can take different courses, and they would not restrict you to follow a certain track of courses like other universities. So that was the main selling point for me. And the other one was the co-op because it was giving me a lot of experience, and also, yeah, as professor said, some pocket money to also like help you explore other stuff. So I chose Northeastern for that. And coming to my experience at Northeastern, first semester was really great. I got to take a lot of new courses and meet a lot of new people in the campus. And yeah, I joined as a research assistant with Professor Sipai himself later on during the summer. And we were working on a really cool drone project. And midway through that, I got my internship at a robotics grocery automation company. And it was through actually NUWorks. So NUWorks is a website where Northeastern students are actually filtered out for the co-op opportunities. And there's really good number of employers where they come to Northeastern and have a good relationship with them. And they choose Northeastern students over other students when you apply through NUWorks. So that's a really good way to secure an internship. And my internship was around for 4 months. It was during fall semester in 2024. So I was on site in Philadelphia, and the internship was really great. The people were really cool. They gave me all the housing and everything, and they also provided me the accommodation and also the transport to the location. Yeah, so it was a pretty cool internship. And after that, I came back, and yeah, it was pretty cool, I would say.
Perfect. Thank you so much. And then, so of course, there's always ways to keep in touch with us. As you've seen, there's multiple events and there's going to be more sessions that you will have the opportunity to attend throughout now, all the way until you are fully on campus. But these are just ways to connect with us. Our emails are pretty active. I know my team, as well as the advisors team, they're super on their email, like our turnarounds less than 24 hours. And of course, we're on social media. So definitely track where our student ambassadors are. You could track where the missions team is. And this is just a good way to just reach out to us and just stay in the loop until you are fully immersed on the campus. And then, of course, I'm going to open up to Q&A. So I do know there are some questions that came in, and I appreciate Kirsten and Laura answering them as they've been coming in, but definitely type your questions in. And if Kirsten and Laura, if you see a common question that you'd like to address out loud, please feel free to do so.
Thank you. And indeed, I mean, I can actually recognize some names and the attendees, and they've been emailing me, and we were in touch, and which I encourage. If you have any questions, feel free to reply, email to me, and turnaround time is quite fast. Some of you might know that because we've been corresponding. And that is something we promise, and that is something we enjoy doing. So really important is that we don't want to think about the program as a standard path. Everybody follow the same thing. Everyone's learning needs are different, and everything is customized for each one of you. And that's why we have these one-on-one interactions starting now, and as you are here, likewise. And I always say that I mean it. In our program, you're not a headcount. And so let's take some questions. Pujit, did you go for a co-op?
Yes, Professor, I went for a co-op.
Tell us a little bit. What's the
So
process? What did you do?
well, it was a systems integration engineering role. So it was more of like a mechatronics role. Like, you know, it had software, hardware, and controls to it. So my role was to basically set up the automation systems over there, calibrate them, and then debug any problems that come up during the calibration process and the setup process. And yeah, I was basically coordinating between the software, hardware, and the controls team. And I was basically telling them what was happening, and I was giving them I was trying to find the root causes for the problems, and then I'd come up with solutions and ask them to change this parameter and that parameter in the design, so we don't have issues in the next phase. So it was more of like a mechatronics. So it was actually really nice.
Thank you. I think the questions online were answered.
I think a question I think probably would go for you, Professor Safai. I know some students are always hesitant between Boston campus and Seattle, usually within our network. And I think a common question is like, is the curriculum different? Like, what are some advantages or disadvantages? What are some advice or some things you would say to students that are debating, like, oh, I got accepted to the Seattle, but I don't want Seattle, I went to Boston, about the program? And normally I know a lot of us say it's usually the same layout, like there's no difference between our network, but I think if you address that, that may help a little bit more.
Yeah, I mean, our goal and our really commitment is there will be no difference in learning, and we want to make sure that the quality of the program carries over to Seattle. One reason we are present in Seattle now is, as many of you know, there is a very huge aerospace industry there, very strong aerospace industry and robotics industry, and with unique opportunities that the students actually will be able to connect because they will be locally in that area, whether that be maybe a co-op interview or some opportunities with companies that are obviously different in nature than those around Boston. And this was a strategic decision because we know that there is a strong industry there that is in need of a talented robotics workforce, and we therefore decided to actually show our strong presence there, and we are committed to having the same quality in Seattle as we do here in Boston.
Great, thank you.
Is there one more question? Let's see.
I know there's been some questions about like course availability, and that's always like a concern for students, I would say. Our team hears a lot about it. I'm sure Rifat and the other program contacts hear a lot about it. The good news is that students, like Rifat mentioned in one of the responses, students in the long term don't have issues getting into the courses that they need. I know it seems like it's competitive, and it is in a way to get into those courses, but there's plenty of time to get into your core courses. The advising team and the departments are really willing to work with students to get into the courses that they need. So we understand the initial frustration or panic, but just know that you will get into the courses that you need, and we will help you in any way that we can.
Yeah, just to give you a little bit more detail, right now the students are transitioning into Northeastern, but once they are in the pipeline, to give an example, in the fall, around October, students will be informed the spring semester registration will be opening soon. And there's a deadline by which the courses are posted in for the spring, but you cannot register yet. And that is about 10 days of time frame. Every student has an opportunity to see what's going to be offered in the spring, but nobody can register because it will just create some crazy competition. You have enough time to kind of to take a look what's being offered, and you can make a plan. And then there is a time that students are actually allowed to start registering. So there is actually a coordination of managing this. And I can assure you, nobody failed to graduate because they couldn't take a core course. And everyone has taken their core courses without exception, and everybody graduated on time. For sure, there are courses that are more competitive or they are more popular, and that is true. But there have been no issues that I know of, and I know very well what's going on in the program. So don't worry, don't panic. Some courses have wait lists. Put yourself on a wait list. And believe it or not, some students are shopping around, so to speak. They will actually drop the course and then move somewhere else, and then you'll be bumped up on the wait list, and you may get into the course. But have a backup plan. Keep yourself on the wait list. But in the meanwhile, register for 2 courses that are the most, let's say, valuable to you. But keep an eye on the wait list. And if not this fall, next spring, you'll be able to get into the course you would like to get it. So. There's a question about TAs and RAs, and there is no written rule that TAs and RAs are for PhD students. Most of the time, they are teaching assistants. We would like to have, let's say, academically more prepared students like PhD students who have been in the pipeline for several years now to be able to actually assist students at the master's level or undergraduate level. So, and likewise, research assistants often go to PhD students because the projects that fund the research assistant positions are usually long-term projects, minimum 3 or maybe sometimes 5 years long. And this is not a timeline a master's student will be willing to stay. And those are usually the reasons these financial supports go to PhD students primarily. Nevertheless, and Pujit can speak to that, I myself had funding that had a shorter term, about a year. And it will be impossible to find a PhD student who I can fund for a year. And what about the remaining 4 years? So in those cases, we actually closely work with master students and we pay them. And then Pujit actually was one of those really excellent students that joined my group, and I was able to financially support his work within the scope of the project. And so these opportunities are there. They may not be as many as maybe an RA opportunities, but there are some mechanisms to provide some financial support to master students. In addition, especially second-year master students, both in electrical and mechanical engineering, we recruit some of those top GPA students as graders on a hourly basis stipend to help instructors grade midterms and or homeworks, most of the homeworks, and students paid an hourly rate. And so those usually are provided to second-year students because students have had a chance to demonstrate some proficiency in certain courses, and we recruit them as graders. Again, if most of the core courses are full now, don't worry and don't panic. There is, again, a good number of electives you can start with. Most of the electives, except maybe 7,000 level ones, most of the electives don't have a prerequisite. And some of those electives are intended to be a funnel in courses to onboard the graduate students to the program in their first semester. So do not worry. And then if there's a wait list, make sure you put yourself on the wait list. Kristen, thank you. You're typing super fast.
Part of the job. I do want to also say that for academic advising, we do have bi-monthly or monthly virtual office hours. I'm going to go ahead and put the link in the chat for everybody. And this is our next one is on July 17th from 10 a.m. to 11 a.m. And this is a time where students, such as yourself, as incoming students, can come in, ask a question to either myself or another advisor. We're more than happy to help. And if we don't have the answer, we'll at least direct you to who will. But that is a great resource, and as well as checking your degree audit as well. So definitely feel free to connect with us. Another one, the best way to contact us is through email. I'm going to go ahead and put that in the chat too as well. coe-gradadvising@northeastern.edu email, as Hirsch mentioned too. And yeah, we're more than happy to help.
A quick question here from Xander. I'm sorry if I'm not pronouncing your name correctly, about what type of research projects are underway at the Institute for Experiential Robotics. Just to give you a sense of the types of projects there's underwater robotics, and there is a drone area for autonomous flight control. And there is ground robotics potentially combined with aerial robotics type of works where single or multiple robots need to do some coordinated movement or planning, which includes trajectory planning and some type of controls together. There is also strong efforts in interfacing humans with machines, and this is in the context of rehabilitation robotics. And primarily, we have two faculty working on lower limb rehabilitation and with passive and active devices. And we also have faculty who are developing robotic systems that interface with the humans, similar to an exoskeletons, which can be used for remote applications, such as one a human has to wear a robotic system, and as they actually move the robot, a copy of the robot in a remote location will be able to mimic humans' motions. And so teleoperation type of research is ongoing. There's also a large number of computer science, machine learning type of work that also is happening in integrated with robotics, including vision-based control, machine vision type of work, and a lot of work in learning through data and experience. So it's quite broad. If you actually look at the list of courses, that will give you an idea of what research is happening, because usually faculty who does research in a particular topic will give a course in that topic. So it actually, the list of courses and the topics of the courses will give you a hint about what type of research is happening on campus. Okay. I'm just checking if there's anything that I could maybe add. Yeah, another means to actually really get involved, and although these may not be paid positions, getting into a research lab and getting your hands kind of dirty with research is actually really a good way to start showing what skills you have and what you can do and how you can contribute. So there are opportunities. They may not be paid, but they may pay off in the long run. Maybe a company is partnering with a lab, and you're in the lab, which gives you a connection with the company. You start networking. So there are many other ways you'll be able to engage in research and companies, and also network with your students, with your peers, and with your professors whose courses you have taken. So this is an activity of, let's say, research slash networking, which is really, really critical. So these can open some doors, although they may not be paid financially at the beginning. They may actually offer some opportunities in the near future. Here's a question from Ananda asking about full-time offers and the benefits students gain from the program, which benefit them in their post-graduation journey. A large number of our students actually join the industry, whether international or domestic. And again, a good number of our international students also pursue co-op, and they go and work with a company, at a company for, let's say, 4 to 8 months. And some of those eventually convert to full-time employment. And it depends on a number of things, but it's not impossible that a student does a co-op, comes back to classes, graduate, and then they keep in touch with the company, and the company gets back to them with a full-time offer. So we have students who work at the intersection of mechatronics, maybe more design slash controls. We have also students who work more on the software side, maybe CS combined with electrical engineering. We have a good number of students in robotics domains, and Pujit and I know one student, for example, who just graduated from our program. He got employed full-time in Amazon Robotics, right, Pujit? And an international student who went through our program and gained and had significant experience already, but gained a lot, and eventually graduated and received a full-time offer from Amazon Robotics. He's a robotics engineer there right now. We see our students in really great, strong industry roles, and that makes us excited. A small portion, as is the case, pursue PhD, and that's also another track. So if some of you have goals towards pursuing a PhD, then the master's program, especially with a thesis option, would significantly strengthen your case for competing for a PhD position in the US or elsewhere. So some of our students eventually transition to PhD programs. That's also another track. That's an excellent recommendation, Pujit. Look for a skill that not a lot of people have. And hopefully, and ideally, it should be a skill that you would like to have, right? Don't force yourself to a skill that you don't want, but look for a skill that is actually unique and that can give you an edge, a difference. And then look for a faculty or a course a faculty teaches, and pursue that skill and try to develop that as strong as possible. And in some cases, that skill is not available through a course offering. So the best would be to work with a faculty in a lab setting and acquire that skill. And then some of these skills are acquired through some kind of an apprenticeship type of relationship with a faculty. But again, they pay off significantly because some of these skills are rare, but they are on high demand. And if you equip yourself with those skills, then you'll be significantly competitive in job search. I always advise students, once you arrive here, don't rush to graduate, because make sure you have the skills before you leave. And after you graduate, it becomes more difficult to acquire those skills because you have other things to worry about. And so try to optimize the time you stay here and what you learn so that you actually build the best portfolio before you start competing for serious jobs. And you will be able to do that. And we have a 1-credit co-op course, which actually prepares students for interviews, resume building, how to present yourself, how do you engage with employers, human resources at companies to be able to present and market yourself. So we have actually a 1-credit course that actually prepares you for many of these professional scenarios. We would recommend taking that 1-credit course, and it's a required course if you like to go on co-op anyway. All right, let's see if we have more questions. What's one piece of advice will you give for incoming students to make the most? Before arriving, Xander, sorry again if I mispronounce your name. Before coming to Northeastern, if you have time, refresh your statistics background. If you have never taken statistics before, it doesn't mean you can't figure it out on your own until you arrive. So look for an online course, look for some course contents, and refresh your notes. Statistics is going to be really, really critical because it's going to enable you to take some really advanced level courses at the machine learning and reinforcement learning type of courses, deep learning types of courses. Without statistics, you will not be able to advance your knowledge in those very hot topics. If you have time, refresh your coding skills. You don't have to spread thin. Pick one coding language, whether it's C++ or MATLAB or Python, and practice coding. Some of our courses assume you know how to code. And so you would like to be ready when you jump into a course and then week 2, you have to code something, you want to be ready. In some of our courses, we have intro level coding. So the instructor will actually show you how to code. But most of our courses also expect you to become more independent. So you'll be doing a lot of outside of class work to be able to catch up and learn and polish your skills. Now, one piece of advice after you arrive Northeastern would be try to pursue a learning opportunity that differentiates you from others. If you have a mechanical engineering background, look for something else in your electives, for example. And if you take more mechanical engineering courses as your electives, you will not be differentiating yourself significantly from others who are doing somewhat the same in their comfort zones. So look for those boundaries where you actually push yourself out of your comfort zone to a reasonable level. And because a mechanical engineer who has computer science skills is rare. Likewise, an electrical engineering student who can do computer-aided design is rare. Employers are looking for those combined skills. So try to combine your skills strategically so you have a skill set that is not available in a single engineer. And that would be one advice I would give you. There's a question about Silicon Synapses Lab. Pujit, you already answered. Okay.
Rita, we actually have a question about that maybe you might be able to answer about how big is entrepreneurship community in the Boston campus, and how common is the lab to market pipeline in regards to the robotics lab?
That is a good question. First of all, we're a very strong business school here. And although the following caters primarily to undergraduate students, I can give you the following advice. We actually have a student club that interfaces engineers with business school students. And sometimes this club receives external funding, or maybe a faculty sponsor comes up with an idea. And in this club, business school students actually work together with engineering students to actually create commercially available products and launch these. Some of these eventually end up being startups. So there are these opportunities. I mentioned them because the university is actually very entrepreneurial minds, has a very strong entrepreneurial mindset. And you will not be surprised seeing engineers working with business students, business school students, because it's in the whole heart of the co-op, and the innovation and entrepreneurship comes with it. So you will be surprised how many of our engineering students think that way, and you'll be able to find ways to connect with resources that can give you a business way of looking things. You will not be able to take business courses. So I should also mention that, because that doesn't support the MS Robotics program. But you will be exposed to business-minded people, and you can actually leverage those. That was a good question. Now, speaking about the entrepreneurship community around Boston, Boston, as you may know, has become the robotics hub in the US right now. So there are numerous startup companies in the general area of robotics. There's a huge incubation spaces around Boston, South Boston, where robotics is flourishing. So entrepreneurship is in the genes of, let's say, robotics in Boston. Yeah. Let's see.
We have another one
Mm-hmm.
about suggesting 3 to 4 subjects that students can brush up on to have a strong hold so they can make them stand out. I
Sure.
don't, yeah.
Before coming to campus, I would strongly recommend working on statistics, coding, whether again C++, Python, or MATLAB, some coding, or robot operating system, ROS. Pick one and do a deep dive and brush up statistics. Brush up maybe some of your advanced math courses from undergrad. When I say advanced, I'm talking about differential equations type of topics, and integrals and differential equations. I would brush those up because they will constantly arrive at you, and you'll be expected to know those topics. And the advanced math in undergraduate, I would say. In addition, if you have time, a robot operating system is obviously is one of the standards. If you have time to have some background on ROS, would be really valuable, because some courses use ROS directly, assuming that you know how to code. Even if you don't, you'll be able to survive. Never seen anyone fail a course because they couldn't code in ROS. But if you have the foundation, you will have an easier time. So I would focus on those. Okay, there's a question about switching campuses. There's an email, and let us know. Okay, we went over those 3-4 subjects.
We have a student that wants to know the most equipped lab for mechatronics and robotics among all the campuses. If you can speak to that.
I don't know, Pujit, what do you think? What's the most equipped lab?
I mean, every lab is pretty great. So you cannot grade labs. But yeah, I mean, it depends upon what you want to actually specialize in, what skill you want to actually specialize in. So each lab has a strong point to it. So if you could basically narrow down what technology or what skill you want to do, That way, find a lab. That would be a really great idea rather than just grading a lab with highest, things around.
That would be exactly my answer. I'll give an example. Let's say you want to work on machine vision. That lab may just have a camera. That's it, because they're just working with cameras, right? They may have some supercomputers for high performance computing, but we wouldn't call that lab unequipped because they have everything they need to do some advanced research, right? But then there's another lab that does underwater robotics. They have, mini submarines. They fly them in the Arctic, right? And they don't have maybe fancy cameras for doing satellite research, but we can't call them unequipped because they have everything they need to do to fly their, or to swim their, operate their submarines in the Arctic, right? So like Pooja said, it depends what lab is doing what, and they're not really compatible because their needs are different, but they're all very well equipped. I can attest to that. Okay, these are very good questions. Do we have more questions?
I was going to say we're almost at the top of the hour. So if anyone
Okay.
has any more questions, we definitely advise you to type it in, or you could email myself in the admissions office or in student support services, and we'll definitely answer those. But these are great questions. I appreciate all of you answering them. And I hope that all your questions or any questions that someone had and then you had, and then all of that's been typed in and answered. And we really hope that this was very helpful for all of you.
Yeah, there's a question about course waivers. Priyanka asked. We have an electronic process that we use to manage paperwork. So the procedure starts as follows, more or less. Let's say there's a course that you would like to take, but it has a prerequisite. But maybe your undergraduate course that you have taken, maybe you think may help you waive the prerequisite, so you can initiate a petition through the electronic system, and you fill in the instructor's email, and you state the purpose why you're requesting a waiver, and then that electronic document gets rerouted to the instructor, and you attach your transcript. And this happens quite a lot for statistics as an example. And you took a stats course in undergrad, and you want to waive the prerequisite for a machine learning course, and it happens quite a lot. Students requests a waiver, the instructor looks at the transcript, and then they will say, sure, this is good enough for you to jump into the course. And then that eventually gets in the system, and then somebody then will be able to put you into the course, although you don't have the prerequisite. So there are mechanisms to do that. So don't rush to take the prerequisites, explore ways to see if you can waive them first. But there are some barriers too, and for good reasons, because we don't want someone to fail the course because they lack the sufficient background, and that's not something we want to see. And we don't want to set someone to failure either. But if we have reasonable belief that they have taken a course that supports as a prerequisite, then we are more than willing to allow you to take that course and waive the prerequisite.
Thank you so much. Well, once again, we'd like to thank everyone that joined us today, and we hope this was helpful. And you will receive a follow-up email, and the recording will also be shared within that email. So once again, thank you, everyone. Enjoy the rest of your morning, evening, or even afternoon. Take care. Bye, everyone.
Thank you. Thank you, everyone. See you in September.